What we're going to do is you're going to try and use the kits in front of you to show the interactions between water molecules and some of the other compounds that are in the kits. And with this video, what I'll do is I will provide you prompts and I will let you attempt to try it, but then be able to see the answers. Okay, so first thing we need to do is we need to look at water and see what kind of intermolecular forces it forms with itself. So here we have our water molecules. So now pause and add the intermolecular forces. Okay, so now if we look, we know that it is a polar molecule. We know that they'll have London dispersion forces because they're between everything. And as a result, they have London dispersion, dipole-dipole, and hydrogen bonding. Now, you'll notice that I didn't put a dipole-dipole or a hydrogen bonding between these two molecules because it wouldn't form between them due to their orientation. The slightly negative end of this molecule is not pointed towards the slightly positive end of that molecule. And so that's why I didn't include it. And this hydrogen could potentially be attracted to the lone pairs on this oxygen, but because of how they're positioned, it's a little hard to get at it. Okay, so now we'll bring in our CH2O, methanol. Okay, so add your intermolecular forces. Okay, so now we can see we have a polar bond, it doesn't cancel out. So now when we surround it with our waters, okay, we have a polar molecule, so add your intermolecular forces between water and your methanol. Okay, so now we can see again, because they're polar molecules, I have my dipole-dipole attractions. We have our London dispersions because they're between everything. I have my dipole-dipole attractions, the slightly negative end of this molecule attracted to the slightly positive end. But in this case, rather than having a two-way hydrogen bond, I have a one-way. The water, because it has a hydrogen bonded to an oxygen, can be attracted to the lone pair on this oxygen. So water forms a hydrogen bond attraction to the methanol. Methanol lacks a hydrogen bonded to an oxygen, nitrogen, or fluorine, so it cannot form a hydrogen bond attraction back to the water molecule. So as a result, we call it a one-way hydrogen bond. Okay, let's take a look at one more molecule. Okay, so our SO3, sulfur trioxide. So add your intermolecular forces to it. Okay, so now we can see there's polar bonds, but because they're equal poles in all directions, they're going to cancel out. And this is a nonpolar molecule. So now take this molecule and place your waters around it and add the intermolecular forces. Okay, so now I have my waters placed around it. I have my London dispersions because they're between everything. Even though water is polar, since my sulfur trioxide is nonpolar, dipole-dipole attractions don't form between it and water. But because my sulfur trioxide has 3 oxygens, my water molecules can form hydrogen bond attractions to it. And so as a result, since there's one-way hydrogen bonds and a London dispersion, I would expect this to have a moderate solubility in water. Okay. Now you try with the rest of the molecules in the kit. Discuss with your classmates.